loving
I
it.
brought back a couple of them.
Oh, thanks, Zach.
I was gonna say, cause I'm gonna get you some.
I'm glad I didn't protect that.
Me too. Okay, so I'm doing 5-3 today. I'm gonna do 5-4 tomorrow. 5-4 is, I just lost my brain. 5-4, is a lot more difficult, okay? It's factoring. If you don't know how to factor, this one's gonna get you, okay? Your test is gonna be Thursday, Friday over 5.1 through 5.4. If you are absent Friday, you have until Monday at 3:25 to make it up. If you are absent Thursday and Friday, you will have until Tuesday at 3:25 to make it up. If you don't take care of your business, you will get a 0 on that part of the test. Okay? I'm not playing with y'all. It's spring semester, and every Thursday and Friday, nobody comes to school. Everybody's off gallivanting around, playing softball, baseball, golf, tennis, track, and everything else in the world. I'm still having class. So watch the videos on YouTube and get your stuff done. So before I do 5.3, okay, I'm going to do 5.2. If I'm going back and doing another graphing problem, do you think it's important?
Yes.
Okay, so here we go. F of x is equal to -2 times x plus 3 quantity squared times x minus 1 times x minus 2.
Wait, but that's not what the ones on the.
I'm going to show you, I'm going to talk about that because really there's only one thing that you have to do different about the ones on the worksheet. Okay? And y'all, it's a skill you already know. No, we're going to work it together because I don't have time to let you work it and then teach my stuff. Okay, so I'm just drawing a graph, sorry. All right. So the first thing I want to do is I want to find the zeros. Y'all, every time they ask me to graph something, this is what I'm going to do first, find the zeros. Now, the ones on the worksheet, you actually had to put them in y equals and then find the zeros. Should you be able to do that? Talk to me, please. We're on the video.
Yes. Yes.
Yes, you should be able to find zeros from a graph. If you can't find zeros on a graph, you better go back and look it up. Figure out how to do it, okay? So, but this one, I don't have to do that way. I can look up here and find my zeros. If x plus 3 is my factor, what's the 0? -3. And how many times does that -3 occur? Twice. This factor occurs twice. So -3 must be a what? Double root. If x minus 1 is the factor, what's the root? +1. Okay? Don't forget that if I had said 2x minus 1, it would have been 1/2. Okay? Don't forget that if you have a number in front of that x, you have to divide by it. This is just a 1, so he doesn't change anything. If x minus 2 is my factor, what's the root? All right, so I said that you had to have a T-chart. You agree? Mm-hmm. And in this T-chart, I said I want zeros and relative mins and maxes. Everybody agree with that? That's in your notes from Friday. All right? So, so I know my zeros, so I'll put them in here. -3 is a double root, so -3, 0, 1, 0, and 2, 0. Okay, now I want to bring something to your attention. Well, let's talk about this first. I'm going to go write them on there. -3, 1, and 2. I just graphed them really quick. Okay? The next thing I want to know is what is the degree of this polynomial? No.
5.
No.
Oh, it's 2.
No.
No.
gonna show you two ways, again, all right? If I square this binomial, what does this guy end up being? X squared. Do you agree with that? Square the first, keep the sign, twice their product plus square the last. If I multiply these two with the full method, when you multiply first times first, what will you get? X squared. What will x squared times x squared be? X to the fourth. So what's the degree of the polynomial? He's a fourth degree polynomial. All right? Now, let me show, y'all think about this. All right? When you multiply, what do you do with your exponents? You add them. What is 2 plus 1 plus 1? That's 4. Do you agree with that? Okay? So that's two different ways to look at it. I don't look at it this way up here. I just look across there and I'd say, well, that'd be an x squared, this would be an x squared, so x squared, that's x to the fourth, it's a fourth degree. Would that be an even degree function or an odd degree function?
Even.
He's even. Tell me what that tells me.
They end up in the same way.
Yeah, his beginning and ending directions are the same, right? He begins and ends in the same direction, either both up or both down. All right, what about the leading coefficient? Yeah, it's this negative. This would be an x squared times an x squared, be an x to the fourth, negative 2x to the fourth. So my leading coefficient is negative. What behavior does that tell you?
Then down.
Yeah, where he ends up going, not where he came from, but where he ends up going. So he ends up going down, negative. Because he's even, he does the same thing on both sides. So he has to start down too. Are you with me? Okay, so watch what's going to happen over here. From this 0, right, let me talk about this for a second before I do that. If this is a fourth degree polynomial, how many solutions did Freddie Goss say this thing would have? 4. Okay? 4. So do we have 4 solutions?
Yes.
Yes. We have 1, 2, 3, 4. Okay? Now, what on your worksheet, you had some problems like this. I don't remember what it was. I'll say 3. Okay? And then you graphed it in a calculator and found the 0. How many zeros did it have?
2.
1.
1.
1
Okay.
0. 1 0. How many is he supposed to have? 7. We only found 1 of them. Y'all, he only crossed that X. Y'all, look, this is what he looks like. He only crossed that x-axis 1 time. That was the only 0. What about the other 6 guys?
Were they just the same?
We can't, no. No, they're not, okay? So, what kind of zeros are not on a graph?
Oh,
Imaginary. So the other 6 are imaginary, all right? Does everybody understand that? They're imaginary. So they're not gonna come. You would have to find a different way to find those, all right? So, we're not going there. I just asked you to put the zeros in your T-chart, okay? So if you put -1, or that's not even a 0, whatever this 0 is, when you looked at it on your calculator and found it, all right? So, now, go back to here. He starts down, so this is the first 0 that he hits, so he's going down from here. Do you agree? Now, what is the multiplicity of this 0? How many times does this factor occur?
1.
2. So it's even. So what does he do at that 0? Evens, they don't cross. Evens, they bump. So he bumps and comes back down again. I don't know how far he comes. I'll have to look on my calculator and see. Okay? But do I know that he has to come back up somewhere?
Yes.
People, he's got to hit right here. So he has to go down and he has to come back up. Now, what's the multiplicity of this 1? He's 1, so he's odd. So what does he do? He crosses and goes up. Don't know how high. But I do know what? He has to come back down because he has to hit that guy again. This is my 2. his multiplicity is also a 1. So he crosses it and keeps going down. Okay? So what do I need to do on my calculator? Find this relative min and find that relative max. Okay? So I'm going to put this in my calculator. I'm going to go to y equals, clear out that graph, clear out this graph, and I'm going to put him in there just like he looks right here. -2, open parentheses, x plus 3, close them, square it, open, x minus 1, close, open, x minus 2, close. I'm going to go zoom 6, and I'm going to graph him. All right, he's looking pretty good. Looks like he bounced off this -3, just like mine does. He looks like he crosses at a 1 and a 2, just like mine does. So I noticed that my relative max and relative min are not on my graph. He can't find it if he's not looking at it, okay? So who do I need to change, the x's or the y's? And where do I go to do that?
Window.
Very good. So I'm going to go to my windows. I don't care about the x's. The y's, I'm going to make them bigger. So I'm going to go -20 to +20. And I'm not worried about the scale right now. So I'm going to graph him. I see I did not catch this guy right here. But I did catch this guy, so I'll go ahead and find him. So I'm going to go second and calculate. What is he?
The maximum.
A maximum. So I'll choose number 4. Now, look at this, because this calculator's telling me something. He says, hey lady, I'm way down here at 0 and -36. Okay? Is this minimum below that number?
Yes.
It is. It's on the left of it, so it has to be below it. So that right there says, wow, I gotta go down a lot farther than what I did. All right? So but I gotta go up here. I'm looking for a left bound on this max. So I'll push my little spider up there. There's a left bound. There's a right bound. And there is my max. He is at 1.6, 10.2. Okay? Do not call that 2 and 10. It is not 2 and 10. Okay? First of all, 2 is already 0. All right? So 1.6 and 10.2. Here's how I'm going to graph it. 1.6, 10.2, bam. This is my max. I'm going to label it on my T-chart. I'm looking for this min, so I need to go back to my windows. I need to change my minimum to something a lot goes down lower. So I'm going to just do -50. I'm going to graph it. If that hadn't have taken care of it, I would have probably gone to 100 because I got tired of playing. All right, I did. I barely made it. So there he is. I'm going to go second and calculate. I want number 3, a minimum. He wants a left bound and a right bound. And here it is. -0.8 and -48.8. Okay? So I'm putting him in my T-chart. -0.8 and -48.8. And that's my minimum, so I'll label it. Now, watch what I'm going to do over here. Do I want to make 48 tick marks? No, people. Just pop him down here and say, hey, Miss Davis, this is -0.8 and -48.8. And go, it's way off my graph, so there you go. Anybody got a question? So the only thing that was different about the ones on your worksheet is that they weren't written out all nice and pretty like this one was. They weren't all factored, all right? So you had to find the zeros. I couldn't just look at it and tell the zeros. I had to find the zero. Should you be able to find a zero? Yes, people. Second and calculate. Number 2, a 0. I'm going to find that one right there. So left bound. Right bound. 1, 0. So that's what I want you to do. Anybody got a question? Nope? All right. So now let's move on to 5.3, okay? We are going to add, subtract, what, are we going back to the 3rd grade? And multiply, oh no, we stepped it up to the 5th grade. Polynomials, oh, back in high school, too bad. All right, add, subtract, and multiply polynomials, all right? Remember that your test will be Thursday, Friday, and it will be over 5.1 through 5.4. 5.3 should be a breeze, all right? So, on the adding and subtracting, I'm only gonna work one of each unless you say, Miss Davis, I'd like to see another one, and then I'll work another one, all right? So here's example 1. I want you to add, write this down as I say it out loud, okay? Let's go, write it down. Add 2x to the 3rd minus 5x squared plus 3x minus 9. And x to the 3rd plus 6x squared plus 11. So when I add two things, all I have to do is put what in the middle? Yeah, just put a plus sign and then combine them like terms. So I'm going to write it 2x to the 3rd minus 5x squared plus 3x minus 9 plus this guy, x to the 3rd plus 6x squared plus 11. All right? I want you to write these in standard form. So I want you to start with your highest exponent. Who is my highest exponent?
3.
To the 3rd. So here's a 2x to the 3rd. Are there any more x to the 3rd?
Yes.
Okay, what is 2x to the 3rd plus 1x to the 3rd? Very good. 3x to the 3rd. What's going to be the careless mistake? Someone says 3x to the 6, because we've been multiplying and adding those exponents. Okay, so be careful with that. Those are gone. And then I have negative 5x squared and a positive 6x squared. What does that give me? Plus x squared. Now these are gone. Alright. I got a little plus 3x. Does he have any like terms? No? So we just write him down. Alright. And then I get a negative 9 and a positive 11. Plus 2. And there's my answer. Anybody got a question? Do you agree these are kind of easy? Okay, so let's do a subtraction one. Example 2. We are going, this has two things that I want to make sure that you know. Okay, so be very careful with the subtraction one. We are going to subtract 3x to the 3rd plus 2x to the 2nd minus x plus 7 from 8x to the 3rd minus x squared minus 5x plus 1. Okay, so the first thing I want to make sure of is that you know who goes first. Why?
Because you're saying, so you're subtracting that from it, you're taking that away from it.
That's exactly right. So if you're subtracting this guy from this one, you have to have this one first. Okay? Is he first because 8x to the 3rd is bigger than 3x to the 3rd? No, people, it has nothing to do with that. Okay? So put this guy first. 8x to the 3rd minus x squared minus 5x plus 1 minus. Here's the second thing I want to make sure that you know. If I'm going to subtract this whole polynomial, what do I have to do with it? Yeah, I'm going to put it in parentheses, okay? Now let me tell you why. Because if I just write a minus here and then change all the signs, when I was glancing back over my notes, I might not see that, okay? So, but that's what the parentheses are going to do. If you only put the minus and then write that guy down, you're only subtracting the first term, not all the whole thing, all right? So minus 3x to the 3rd plus 2x to the 2nd minus x plus 7. Now, what does a minus sign outside parentheses mean? Yeah, we just change all the signs. So the opposite of a positive 3x to the third, is a negative 3x to the third. The opposite of a positive 2x squared, negative 2x squared. The opposite of a negative x is a positive x, and the opposite of a positive 7 is a... And now he looks just like the problem above, right? We start with my highest exponent, which is what? So I have 8x to the third minus 3x to the third. Yeah, y'all listen to me. You would be better off if you said these out loud to yourself. You know how to do that? You all know how to talk out loud in your head without saying it out loud. Okay? You've all walked by that person in the hall or on the street somewhere and went, what did they have on? Oh my gosh. Or something. Okay? Or wow. No, I'm not.
You showed me that one.
How often do you do that with your mistakes?
Why you gotta judge people? Why are you?
I'm not. Sometimes I don't know. Never mind. I'll quit. All right. So next, what is a negative x squared and a negative 2x squared? Negative 3x squared. Very good. What's a negative 5x and a positive 1x? Now y'all listen to me. Some of y'all are going to make crazy, careless, stupid mistakes on these things. I promise you, you can't afford them. What is 1 minus 7? And there's my answer. All right. Anybody got a question? Okay, so what's next? Multiply. Example 3. This is what it looks like. Negative 2y to the third plus 3y minus 6. And we're going to multiply it by y minus 2. Now, you already know how to multiply binomials, okay? A binomial times a binomial. You're using the full method, all right? So this is a trinomial times a binomial. And here's the rule. Everybody gets multiplied by everybody, okay? I mean, that's it, people. That's essentially what you're doing. Everybody gets multiplied by everybody. But we want an organized way to do that, all right? So here's what you generally do. You take the smaller y minus 2 and you split it up and you multiply it by this guy. So first I'm going to multiply y times the longer polynomial. Negative 2y to the third plus 3y minus 6. And then I take the other half of it. And y'all, this is a minus 2, so you would probably take the sign. But even if it's a positive 2, you still put plus 2. Okay? So minus 2 times, I don't know what you did. Oh, okay. So then negative 2 times that whole polynomial. Negative 2y to the third plus 3y minus 6. All right? Now, if you look at my notes and you pay attention to what I do in class, I always do this because the most common mistake is just to multiply the first term by the y, okay? The next thing my brain says is, hey man, all it's going to do is increase the number of y's that everybody has by 1. All right? So this becomes negative 2y to the what? 4th. This becomes what? Plus 3y squared, and this becomes minus 6y. I'm going to do the same thing here. Now this time, my brain's going to say, oh, you better be careful distributing a negative. It's going to change all these signs right here. Okay? What's negative 2 times negative 2y to the third? Because, Kirsten, I said everybody gets multiplied by everybody. And you jumped ahead and multiplied this guy by everybody and then said, there you go, got the answer.
Is that what you have to do?
Well, yeah, but you also got to multiply this guy by everybody.
I did. Is that a negative 2?
That is, it's y minus 2.
Okay, that looks like a Z. I'm sorry, I thought that was a Z.
No,
That's why.
a Z looks, this is a Z,
She does a line there.
this is a 2,
That's why I confused me.
You're taking it last time. Go.
okay? All right, so this is a positive 4y to the third. What's negative 2 times 3y? Negative 6y. What's negative 2 times negative 6? Now watch what I'm gonna do right here, because the most common mistake is gonna be not to change your signs. Change the sign, change the sign, change the sign. I'm all good, all right? So I'll write my answer, start with my highest exponent, this guy right here. Negative 2 oh, sorry, I wrote the problem down wrong. I was wondering why I got that answer and it didn't check with my other notes. I'm like going, what? But I wrote the problem down wrong. It's okay, it's no big deal. Negative 2, y to the 4th. Are you with me? Okay, good. What goes next? Yeah, 4y to the 3rd. Yeah, make sure you're in order, okay? The people that are gonna watch this video that were in my other class are gonna be like, what? Where'd she get that? Because I wrote the problem, I wrote this, it's really supposed to be a square, but I accidentally wrote a cube, but it's not a big deal, okay? What goes next? Plus 3y squared,
Oh, I did it again,
okay? What goes next? Now, what's gonna be the careless mistake right here? Yeah, people are going, cancel, no y's. No, people, negative 12y. All right, and then plus 12. Anybody got a question? All right, what about one more of these? Want to try one more of these? What?
Yes.
Yes? Okay, let's do one more. Every other class is one and one more. So x plus 3 times 3x squared minus 2x plus 4. All right, you do this one on your own. All right, you do this one on your own. And then all we'll like is one more problem and a cool thing to show you.
Wait, one more after this one?
Mhm. Sometimes I do and sometimes I don't. It depends. If I'm in a hurry, I don't. I'm not a good one. Know your weaknesses. Be careful if you circle them like this. I like to circle them sometimes because it makes them stand out. But be careful you don't run through that negative sign and make it turn into a plus. I still always cancel. Is that what y'all got? Does anybody have a question? Okay, so let's do the last thing, and then I want to tell you something that I didn't tell you yet. Okay, so this is example 4. We're still multiplying. Okay, we're still multiplying. We don't get to dividing until chapter 8. All right? So we are still going to multiply. Now, this is called a transfer of knowledge. So it's taking some knowledge that you already have and transferring it to apply it in this situation. So here's the knowledge you should have. If I say, what is 4 times 2 times 3? Tell me what you would do. Okay. Does anybody multiply 3 numbers at a time?
No.
No. People, Mr. Ryan doesn't multiply 3 numbers at a time. okay? So you multiply 2 and then you multiply by the other one. Does the order that you multiply them in affect the answer? No, it doesn't. What property is that called?
Community.
Commutative property of multiplication, which says that the order that you multiply numbers in doesn't get you a different answer. What's 4 times 2? 8 times 3? What's 2 times 3? Times 4? What's 4 times 3? Times 2? Okay, so it's 24 however you do it. Alright? So watch what we're fixing to do. X minus 5 times x plus 1 times x plus 3. Okay, so I'm multiplying 3 binomials. How many binomials can I multiply at one time? 2, people. Okay, now watch. Let me show you this. Remember when we multiplied strings of numbers when we did the matrix, found the determinant of the matrix? And I said look for 10s because it makes it easier. Okay, so this is what I'm looking for over here. If this were an x plus 1 and an x plus 1, could I multiply that really fast together? Yeah, square the first, keep the sign, twice their product, plus square the last. Alright, so I would be looking for things like that. What if this were an x minus 3 times an x plus 3? Those are called conjugates. Can you multiply conjugates really fast? Yes, square the first minus square the last. So those would be things that I would be looking for. I don't see any of those, so it doesn't matter your order. I'm going to start off and multiply these two things right here. Are you with me? So I'm full in it. What's x times x? And the outers, don't write it down there, people. Okay, the outers give you a positive 1x. Okay, and the inners give you a what?
Minus 5x.
Negative 5x. What is positive 1x and negative 5x?
Negative 4x.
Perfect. What's negative 5 times 1? So now I have this trinomial times this binomial. Have we done this before?
We just did it.
People, we just did it twice. Okay? So I'm going to take the smaller guy. Now y'all look, could you take the larger guy and separate him like we did? Yes. You could say x squared times x plus 3, negative 4x times x plus 3, negative 5 times x plus 3, and multiply it all out. But it's generally easier and faster to do the small one. So x times x squared minus 4x minus 5, and then positive 3 times x squared minus 4x minus 5. I am going to distribute, so I'm going to get x to the third minus 4x squared minus 5x. I'll distribute this 3, and he is a positive 3, so positive 3x squared, negative 12x, and negative 15. Now I'm going to collect my like terms. So my x cubed is my largest exponent, so I'll start with him. He's the only one I have. And then a negative 4x squared and a positive 3x squared gives me what? Negative 1x squared, or just x squared. A negative 5x and a negative 12x make
Negative 17.
perfect, and then negative 15. Anybody got a question? Okay, so I have one more thing to do, and then I'm going to pass out your worksheets, okay? But listen to this. I'm going to teach you a skill. I don't know that it's in your book, okay? But it's a pretty cool skill to have. So I'm going to teach it to you, and then I'm just going to teach part of it today, all right? I'll teach the rest of it tomorrow, and then Wednesday, we should be through Wednesday, or we're not finished. I'll only lack about 5 or 10 minutes finishing up. And Wednesday, I will give you 2 problems and let you work them Wednesday, and they will be bonus points on your test. Because they might take a little bit of time, you don't really have time to do them on your test. All right, so I'm going to give them to you Wednesday, and then I'll get them graded, and you can, get those bonus points on your test. So I'm going to talk about Pascal's triangle. Okay, so Pascal was a famous mathematician long time ago, And he figured out the coolest way to raise binomials to powers, okay? Like if you had x plus 3 to the 6th power, would you want to multiply x plus 3 times x plus 3 and get x squared plus 6x plus 9, and then multiply that by x plus 3 and collect all your like terms, and then multiply that by x plus 3, collect all your like terms, multiply that by x plus 3, collect all your like terms, multiply that by x plus 3? No. So he figured out a way you could do it and just really, really fast, okay? So, and he used this thing that he calls Pascal's triangle. So you're going to have to know Pascal's triangle. Let me write it down here first, okay? And then we'll see what happens. Anybody see anything? Do I have this memorized?
It's not hard, you can do it.
I don't have it memorized, people. I do not have it memorized.
You don't need to.
Do not have enough storage in my small brain to have it memorized. All right? So does anybody see what I'm doing? What?
All you have to do is have the three one and you can just go from there. You add the two top numbers with the other.
Okay, so here's what Garrison's trying to tell y'all. Look, what's 1 plus 1?
Two,
2. What's 1 plus 2?
3,
What's 2 plus 1?
3,
What's 1 plus 3?
4,
3 plus 3.
6.
3 plus 1. 1 plus 4. 4 plus 6. Do you see what I'm saying? You see how to get it? All right, notice it's outlined in ones, so the next row is 1. What's this number?
7,
What's this number?
21,
What's this number?
34,
What's this number?
35,
What's this number?
21,
What's this number?
7.
Okay? Now here's what Pascal's triangle is. These right here are the coefficients of a second degree or a squared binomial. These numbers right here are the coefficients of a third power. These are the coefficients of a fourth power. These are the coefficients of a what? 7. It's always the second number, guys. Okay? That's the 7th power. All right. So if you can do Pascal's triangle, all right, tomorrow I'll show you how to raise things to powers. And then whatever I don't finish tomorrow, I will finish up on Wednesday. And we will get that done. All right, so let me hand your worksheets out. I'm going to turn that video off and then talk to you for a second about your worksheets.
Yes. Good.